Hi everyone, this is the lesson video for Math Module 6, Lesson 10, and we will go ahead and get started on slide 2. So number 1 is asking us to shade the area models below, decomposing tenths as needed to represent the pairs of decimal numbers. Fill in the blank with greater than, less than, or equal to compare the decimal numbers. So for part A, we have 0.23 versus 0.4. So I'm going to show you guys a little trick to help you out so you don't always have to shade in area models. So the thing to do is kind of like when you're comparing regular numbers, look at each place value first and always start with the first place value that you get to. So like in this case, the first place value after the decimal point. So let's look at the numbers in the tenths place. So I have a 2 in the tenths place in 0.23 and a 4 in the tenths place in 0.4. Well, 4 is bigger, so that means that 0.4 is the bigger number. Now, since this is the problem set, you guys know that I do fill in the area models whenever we do a problem set together. So just to show you guys why that is, let's go ahead and fill out this area model. So in this first one, I have a 2 in the tenths place. I'm going to go ahead and quickly change to my highlighter and make it a little bit smaller so it's easier. So that means that I have to shade in 2 tenths, and remember each column is equal to 1/10. And then I also have a 3 in the hundredths place. So for this next line, I'm going to go ahead and divide it into 10 equal parts because that will be my hundredths section. Okay, so not exactly equal, but the whole point is to get it into 10 parts. And then of those 10 parts, I know that I have to shade in 3. So this is what 0.23 looks like in an area model. Now for 0.4, I have a 4 in the tenths place, which means that I have to shade in 4 tenths, or 4 columns. And I have no numbers in the hundredths place, so I don't have to do anything with that. But right now I can see that this number is in fact bigger because there are 4 columns that are highlighted all together, whereas this one only has 2 and part of a third one highlighted. So again, with part B, if we look at these numbers, we have 0.6 versus 0.38. So again, when you guys are doing either a test or the homework slides, you guys can just look in the first place value after the decimal point. So the tenths place, see that one has a 6, that one has a 3. Well, 6 is bigger than 3, so that means that 0.6 is bigger than 0.3. But again, since this is the problem set, I'm going to go ahead and show you the area model as well. So starting with 0.6, I have 6 tenths. So that means that I have to shade in 6 columns because each column is worth 1/10. Again, it does not have to be perfect, just make it clear that you are shading in 6 columns and not any more or any less. So here I have 6 columns shaded in to show 6 tenths. Over here on this area model on the right-hand side, I'm going to go ahead and show 0.38. So again, I'm going to start with how many tenths I have. So I have a 3 in the tenths place. So I'm going to shade in 3 columns because again, each column is worth 1/10. And then I have an 8 in the hundredths place, which means that the next column I'm going to have to divide into 10 equal parts and shade 8 of those equal parts. And again, not exactly equal. I'm not the best at dividing things into 10 equal parts, but the whole point is to get it close to 10 equal parts and shade in 8 of those parts. And again, once you get that done, you can very clearly see that this area model on the left-hand side has way more shaded in because it has 6 whole columns shaded in, whereas the other one on the right-hand side, it only has 3 columns and part of a 4th. So we're going to do exactly the same thing with part C. So part C, we have 0.09 versus 0.9. So again, we're going to look at the place value that comes right after the decimal point. So we're looking at the tenths place. So on the left-hand side here, I have a 0 in the tenths place. And on the right-hand side here, I have a 9 in the tenths place. Well, 9 is bigger than 0, so that means that 0.9 is greater than 0.09. And let's go ahead and show this in the area model. So I don't have any tenths. I cannot fill in any whole columns. I'm going to go directly to hundredths. So again, I'm going to just divide one column into 10 equal-ish parts. This one so far is looking pretty good. Okay, that might be my most equal division that I've done so far. And now I have to shade in 9 of those hundredths. So I'm going to shade in almost the entire column except for the last part because we're just shading in 9 hundredths. And for this number over here on the right-hand side and in the right-hand area model, I'm going to shade in 9 tenths, which means that I'm going to shade in 9 columns because, again, each column is equal to 1/10. And this one is very, very obvious if you shade in the area model because one area model is almost completely shaded in and one area model is nowhere near completely shaded in. Either way, you should be able to see that this area model on the right-hand side is way bigger because most of it is shaded in. Now, here's where things might get a little bit tricky because in part D, we have 0.70 versus 0.7. So again, I'm going to look in that first place value just to the right of the decimal, the tenths place, and I see that they both have sevens in the tenths place. So normally, whenever this happens, we move on to the next place value. Well, in the hundredths place, there's a 0 here, but there's nothing here. But remember, zeros are kind of just a place value holder. So even though there's no 0 at the end of 0.7, there can be one. So now we write an equal sign, and let's show this in the area model so we can see. So with this one right here, 0.70, I have 70 hundredths. So I could divide this left-hand area model into hundredths and then shade in 70. But you guys know that I'm kind of lazy when it comes to math, and I don't want to do all that work. So I know that one column is equal to 10 hundredths. So if I shade in one column, that's 10 hundredths. If I shade in a second column, that's 20 hundredths. Third column is 30. Fourth column is 40. Fifth column is 50. Sixth column is 60 hundredths. And finally, seventh column is 70 hundredths. So again, you guys could absolutely divide this area model into hundredths and then shade in 70, but you can also just know, well, hey, one column is equal to 10 hundredths. And now on the right-hand side, we have to shade in 7 tenths. So again, one column is 1/10. So if I shade in one column, that's 1/10. If I shade in a second column, that's 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, and 7 tenths. So again, with this area model, we can see that we shaded in the exact same amount. So 70 hundredths is equal to 7 tenths. We're going to continue to compare decimal numbers, but this time we're going to plot them on a number line. So same thing, guys, whenever you're doing a test or working on homework on your own, you do not have to use area models or number lines. But since I am going through this together with you guys, I'm going to go ahead and show this. So for number 2, we are going to locate and label the points for each of the decimal numbers on the number line. Fill in the blank with less than, greater than, or equal to compare the decimal numbers. So same thing, for A we have 10.03 versus 10.3. So again, we can always do our kind of little cheat here of starting with the place value furthest to the left and comparing the numbers. So if we do that, we'd start actually in the tens place this time. Well, both numbers have a 1 in the tens place, so we have to move to the next place value to the right. Both numbers have a 0 in the ones place, so far they're equal. So now we move to the tenths place, the number right after the decimal. Well, this one right here is a 0, and this one right here is a 3. Okay, finally we have some different numbers. And I know that 3 is greater than 0, so that means that 10.3 is greater than 10.03. And now, in order to show this on the number line, I'm going to go ahead and change colors and kind of color code things here. So 10 and 3 tenths. I'm going to plot that one first. Well, this line right here is 10. This line right here is 10.1. And let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines gets us to 10.1. So I know that each of those lines is equal to 1/10. So that means that if this first line right here is just 10, this next line would be 10.1, 10.2, and 10.3 would go right here. And now I'm going to go ahead and share or show the other number, 10, sorry, that was 10.03. And now I'm going to go ahead and show 10.3. Well, if I'm using my eyeballs and I see way down here, 10.3 is already labeled way down here for us. So I don't even need to do any counting because it's already labeled. I'm just going to plot my point right down there. And as usual with number lines, whichever number is closest to the right-hand side of the number line is going to be the bigger number. And let's try something similar with B. And by something similar, I mean let's do exactly the same thing, just with different numbers. So we have 12.68 versus 12.8. So again, I'm going to start off just by comparing the place values. So whenever we do that, we start with the place value that is furthest to the left. So we are starting in the tens place. Well, they both have a 1 in the tens place. So far they're equal, so we're going to move on to the next place value, the ones place. Well, they both have a 2 in the ones place, so again, so far they are both equal. So we're going to move on to the next place value, which is the tenths place. Well, this one over here on the left-hand side has a 6 in the tenths place, and this one on the right-hand side has an 8 in the tenths place. Finally, we have different numbers, so we can really compare these two numbers now. Well, I know that 6 is less than 8, so that means that 12.8 is greater than 12.68. And again, I'm going to color code these and show them on the number line. So let's look at 12.68 first. So if I look right here, I see that this first line is 12.6, and I see that this line right here is 12.7. So that means that this must be 12.61, 12.62, 12.63, 12.64, 12.65, 12.66, 12.67, 12.68, 12.69, and that brings us to 12.7. I continued counting the whole way just to make sure that what I was thinking was correct. So now I need to figure out where 12.68 would go. So again, I just counted through it, but I'm going to double count one more time. So this first line is 12.6. This would be 12.61, 12.62, 12.63, 12.64, 12.65, 12.66, 12.67, and 12.68. So I'm going to go ahead and place my dot right there for 12.68. And now I'm going to go ahead and change my color so I can show 12.8. Well, yet again, if I use my eyeballs, I can see right here 12.8 is actually this line on the number line. So once again, I don't have to count that one, I just have to look and plot. And now you can very clearly see that that pink dot is the one that is furthest to the right, which means that 12.8 is the bigger number. Okay, we're going to go ahead and keep going on to slide 3. Number 3 is just telling us to use the symbols less than, greater than, or equal to compare. As always, whenever you guys get to something like this, you can absolutely draw pictures if you want or need to, but as usual, you guys do not have to. So part A, we have 3.42 versus 3.75. So again, we're going to start with the place value furthest to the left and compare the numbers. So this time we're starting in the ones place. Here we have a 3, here we have a 3. So far they're equal, so we're going to move on to the next place value, which is the tenths place. Here we have a 4, here we have a 7, and we have different numbers, and I know that 7 is bigger than 4, so that means that 3.75 is the greater number. And now we can move on to 4.21 versus 4.12. So again, we're starting with the number that is furthest to the left. So we're starting in the ones place. So 4 ones versus 4 ones. Same thing, so we have to move on to the next place value, which is the tenths. Here I have a 2 in the tenths place. Here I have a 1 in the tenths place. Well, I know that 2 is bigger than 1, so that means that 4.21 is bigger than 4.12. And that's pretty much all we're going to be doing on this slide, is just comparing the place values. So let's look at C. We have 2.15 versus 3.15. Again, we're going to start in the place value that is furthest to the left, so the ones place. So here we have 2 ones versus 3 ones, and we don't have to compare anymore because I can stop right there because I know that 3 is bigger than 2. So that means that it doesn't matter what comes after the decimal point. 3 is way bigger than 2. And let's look at D. We have 4.04 versus 6.02. So again, I'm going to start in the place value that is furthest to the left. So I'm comparing the ones place. So here I have 4 ones versus 6 ones. And again, I don't have to go any further because right away I know that 6 is bigger than 4. So moving on to part E, we're going to do the same thing, starting in the place value furthest to the left. So this time it's the tens place. So I have 110 versus 110. Same amount, so we have to move to the place value to the right. 2 ones versus 2 ones. Okay, same amount, so we have to move to the next place value. 7 tenths versus 7 tenths. Okay, same number, so we move to the next place value. Well, there's no hundredths here, but we do have 0 hundredths here. Well, 0 hundredths is the same as no hundredths, because if you have 0 of something, you have none of it. So really, these two numbers are exactly the same. Part F, we have 1.9 versus 1.21. So again, we're going to start in the place value furthest to the left, which in this case is the ones place. So I have 1, 1 versus 1, 1. So far it's the same number, we can't compare them yet, so we have to move to the next place value, which is the tenths place. I have 9 tenths versus 2 tenths, and I can go ahead and stop right there because I know that 9 is bigger than 2. And now we are ready to move on to part 4, which is telling us to use the symbols less than, greater than, or equal to compare. Use pictures as needed to solve. So for this one, I'm not going to use pictures, but just glancing over here, I do see that we have some numbers that are written in unit form, some that are written in fractions, and some that are written in decimals. So I think I might make my life a little bit easier and go ahead and write everything in decimals. So here I have 23 tenths versus 2 3 tenths. Well, I know that 10 tenths is equal to 1, and I have 2 tenths, or 2 in the tenths place. So that means that it's 2 ones and 3 in the tenths place still. So I have 2.3 versus 2.3. Well, those are exactly the same number. Moving on to part B, I see that I have 1.04 and 1, 1, and 4 tenths. And again, I'm going to just go ahead and rewrite that as a decimal. So 1, 1 is equal to 1. I'm going to put my decimal point, and 4 tenths comes right after the decimal. So now it's a little bit easier for me to compare these two numbers, and I'm going to go ahead and start in the place value that is furthest to the left. So that's the ones place. So I have 1, 1 versus 1, 1. Same number, can't compare them yet, so I'm moving on to the tenths place. 0 tenths versus 4 tenths, and I can stop comparing right there because 4 is bigger than 0, so that tells me that 1, 1 and 4 tenths is bigger than 1.04. Part C, I have 6.07 versus 6 and 7 tenths. And again, I'm going to go ahead and rewrite this as a decimal. So I know that I have 6 ones, so that's going in the ones place. Then my decimal point, and then I know that I have 7 tenths, and that is going in the tenths place, so 6.7. And now I can go ahead and start in the place value that is furthest to the left, which in this case is the ones place. So I have 6 ones versus 6 ones. Same amount, so we have to move to the next place value, which is the tenths. So I have 0 tenths versus 7 tenths, and I can stop right there because 7 is bigger than 0. So moving on to D, we have 0.45 versus 45 tenths. So again, I'm going to convert 45 tenths to a decimal. So I know that 10 tenths is equal to 1. Well, I have a 4 in the tens place, so that means that I have 4 ones. And then whatever is left over right here is going to be my decimal point, so 4.5. And now again, I can go ahead and compare 0.45 to 4.5. And I'm going to start in the place value that is furthest to the left, which is the ones place. I have 0 ones versus 4 ones, and right away I can see that 45 tenths is way bigger because it has 4 ones. And now I am going to go ahead and work on E. So we have 127 100ths versus 1.72. So I'm going to change this fraction to a number, a decimal number, sorry. So I have 127 100ths. Well, I know that there's 100 hundredths in 1. So that means that this is actually 1.27 because 27 is what's left over when I take out the whole. And now I can go ahead and compare 1.27 versus 1.72. And I'm going to start in the place value furthest to the left, which is the ones place. So I have 1 1 versus 1 1. Same amount, I can't compare them yet, so I'm going to move on to the next place value, which is the tenths place. And I have 2 tenths versus 7 tenths, and I can stop comparing right there because 7 is bigger than 2, so that means that 1.72 is the bigger number. And finally, in part F, we have 6 tenths versus 66 hundredths. So I'm going to go ahead and rewrite this as a decimal. So I know I have 0 ones, and I'm going to put my decimal point, and then I have 6 tenths. And then over here for 66 hundredths, I know that I have 0 ones. I'm going to put my decimal point and then write 66 because it's 66 hundredths. And now I can go ahead and compare these two numbers by starting in the place value furthest to the left, which is the ones place. Well, they both have a 0 in the ones place, can't compare them yet, so I'm going to move on to the tenths place. Well, they both have a 6 in the tenths place, I can't compare them yet, so I need to keep going. Well, in this number, there's no hundredths. Remember, no hundredths is the same as 0 hundredths. And if I look over here, this has a 6 in the hundredths place. Well, 6 is bigger than nothing, or 0, so that means that 66 hundredths is bigger than 6 tenths. And that's all this lesson is. This lesson is just comparing the numbers. So if you guys look at the homework slides, which is slide 4, I think it's just slide 4. Yeah, slide 5 is a template. So here, you guys can shade in the area models on slide 5 if you need to use the area models to help you compare the decimal points on slide 4. But basically on slide 4, you do not have to draw a picture if you don't want to. You do not have to use the templates on slide 5 if you do not want to. You just have to compare the numbers by typing greater than, less than, or equal to compare them. I hope this helped. As always, if you have extra questions, you can always watch the other video that is provided for you on slide 1, or you can always leave me a private comment and I will get back to you as soon as I can. Bye, everyone.